Good afternoon. For this talk, I'd like to introduce some of the exciting stuff we've been doing with OPCUA and REST and the OpenAPI definitions, which are part of the upcoming release of the specification. Now, when we talk about REST and OPCUA, it's worth noting that it's not new. It's been there from the beginning. Originally, in the 1.0 of the spec, we had SOAP XML support, and we had two protocols, UA binary over TCP or SOAP XML over HTTPS. In 1.04, which was around 2018, we added in a JSON mapping into the spec because the world had evolved. People stopped using SOAP XML and they moved towards JSON as the standard format for doing web services. Um, However, all of these capabilities were buried in Part 6 as a mapping that was integrated in with multiple other layers of the specification that are designed to be independent of the protocol. So it wasn't immediately obvious to a lot of people that this capability existed. Uh, In addition, we hadn't spent any time thinking about how we could integrate this or how you could access this capability if you wanted to use the standard tooling that people have come to expect to use if they're doing any sort of web-based development today. For that reason, we took a new look at the HTTPS mapping, and we have updated it to provide a much more cohesive and compelling solution for any web developer interested in using OPC UA. So this includes a simplified JSON encoding, the formally defining the specification using OpenAPI 3.0, JSON schema definitions for all data types, adding in support for gzip. And by pulling all this together, we feel that we've got a very compelling solution for you. Now, OpenAPI has become the standard way to describe and document web APIs. And so it provides a schema format, and we've created a schema file, and you can see the Swagger UI on the right-hand side of the slide. That's basically showing the file that we've published. It's available on GitHub. And this file allows you to take it and pass it into different tools to automatically generate stubs that you can use as your basis for developing OPC UA applications. And one common tool available is OpenAPI Generator. It supports a wide number of languages, and we've been testing it with the OpenAPI file that we're publishing and making sure that it's generating useful code. We have examples using TypeScript that are currently in GitHub. It's in the member-only repository for now, but it will be available to all the general public before the 1.0504 version of the specification is released. We are also planning on developing some more examples in other languages, in particular Python. Now, one detail about OPCUA information models is OPCUA information models include a lot of fixed node IDs and browse names, which can be discovered by browsing, but there are a lot of circumstances where if you're writing client code, it's convenient to be able to reference constants that define these well-known node IDs. And so we've updated the model compiler. That is a tool that's been around for a while to generate node sets, to be able to take a node set as an input and be able to produce the node ID and browse name declaration as constants in different languages. And so we currently support C# and TypeScript. We're planning on adding support for JavaScript and Python and potentially other languages based on demand. We also have a way to generate JSON schema It's basically the latest version of the JSON schema spec. That seems to be a bit of a moving target right now, but it's we will update that as that spec. Hopefully, it will eventually become an RFC, and when it becomes an RFC, we'll support that. But for now, we're using the JSONschema.org latest definition. Um, so this tooling that we're updating works with officially released companion node sets, but it could also work with vendor-specific node sets or basically a node set you develop for your own particular server, and you're writing your own client, and you just want to be able to generate those constants so you have them available while you're writing the client. One other subtlety has to do with user authentication. The convention with any sort of web-based programming is you're using the authorization header in the HTTP request. Whereas in OPC UA, we wanted to have a protocol that was independent of the transport. So we had an inline bucket where you put your user authentication. In order to simplify the integration into web technologies, we basically said all user authentication comes from the authorization header that's passed in the HTTPS request, and it's up to the server to basically fill in the appropriate buckets. So you no longer have to fill that information in on the client side, as long as you're setting that information properly using whatever infrastructure you've got to fill in the authorization header. And obviously we support basic authentication with username and password, as well as OAuth 2 with JWAT authentication. Uh, HTTPS client certificates are generally presumed to identify an application. However, they could refer to a user in a uh, web development context. However, it's whatever it's being used for, it becomes a way that the server can use to identify the client and decide what permissions are going to be granted to this particular request. And so every request is going to have a new authorization header, and everyone has to be independently verified. So, as mentioned earlier, we've done some simplifications to the JSON data encoding, which is defined in Part 6. It generally it follows the same rules that we have for all the other encodings. It has 24 built-in types, and with some special encoding rules that you'll need to look up in Part 6 to get the complete understanding of them. Uh, However, we formally described everything that's in Part 6 in the OpenAPI schema. So you can start with the OpenAPI schema. You're going to get everything you need to construct the messages, and you only will need to go back to Part 6 because you want to say, let's say, understand the syntax of the node IDs, which includes the URIs in there. But if you just want to treat the node IDs as opaque strings, you don't even need to do that. So it should be fairly easy for most people to develop clients without even looking at Part 6. The node IDs and qualified names are JSON strings, and this is an important simplification. So we include the URIs in there, the entire URI in there. So it's a self-contained string. There's no namespace index, and you can save it, persist it. You can do simple comparisons to check for equality, and generally what you would expect to see for any sort of identifier for a record in any common API, any common web API. Basically, if you're dealing with a web API, your identifiers are generally strings or maybe integers. And with the new version of the JSON data encoding, that's what you get. Now, structures themselves are JSON objects, and these include structures that are defined within the core specification, as well as any structures that are generated or that are part of companion specs or vendor-defined information models. Now, these schemas themselves, if they're part of a companion spec or a vendor-defined information model, they're not actually going to be in the OpenAPI definition because it can only include the stuff that's in the core. However, we are generating JSON schema files from jasonschema.org syntax um, from the node set. So this can happen automatically from the node set. There's no need for handcrafting it. As long as you got a node set, you run it through the tooling, and out comes a schema that can then be used in addition to the OpenAPI definition. Now, I really want to emphasize what a simplification the elimination of the namespace indexes on the wire. So this will make it so much easier to develop applications. And we know from experience that a lot of people have found the namespace indexes very frustrating. It was a necessary optimization for binary, but we did our testing and we convinced ourselves is that there really isn't that much benefit once you've already committed to using a text-based a format like JSON to start with, which is already fairly wordy. Obviously, on both ends, either in the client or in the server, depending on your application infrastructure, you still may need to maintain your own namespace tables, but that would be internal to the application. There's no need to exchange these indexes, even if you're using a session. Now, there's one subtlety if you're looking carefully at this is an example of a read request, which is, as you could see, is a very simple request, easy to put together, is this service ID. This was necessary for the WebSocket integration, which I'll talk about later. But even though it appears to be a magic number, this number is actually part of the OpenAPI definition. So you don't actually have to remember it. Any auto-generated code based on the OpenAPI definition will give you a constant that you could use to fill in this value. So the structures themselves, now it's one thing to remember about the OpenAPI definition is it doesn't provide any standard mechanism for integrating in multiple schemas where the schemas weren't known when you define the OpenAPI structure. So there's no concept of sort of dynamic typing. And fortunately, this is something that we spent a lot of time thinking about with OPC UA. We've got mechanisms that are already there, in particular the extension objects, and we can just simply take advantage of those. So if you have a structure that is part of an information model, it comes back into the value. You see the value, and then the value itself has a body. Then you have this type ID. This type ID gives you all the information you need to go and look up the appropriate either the node set or the actual JSON schema file once we get the infrastructure in place. But for now, you can just take this information and go get the node set that gives you your data type definitions, which gives you the metadata you need to understand all of the fields that could be in the structure that you got. So we've got this very nice mechanism to sort of go from a generic framework like OPC UA and be able to access the information you need to understand vendor-defined or application-specific extensions that are embedded within the messages. And of course, obviously, the model compiler has been updated to be able to generate these schemas as required. Now, one of the downsides of eliminating the namespace indexes was you end up with much larger messages than you would otherwise, particularly if you have a lot of node IDs where you're replicating the same URI multiple times. For this reason, we wanted to require gzip support as a minimum requirement. You can obviously support other compression algorithms. A lot of web infrastructure gives you a choice of several, but gzip is the minimum, and gzip is the is what you need to support for interoperability purposes. Um, so this, fortunately, the OpenAPI definition sort of takes this into account and basically indicates that there's two possible media types you can get back in your response, either JSON or gzip, depending on what is in there. However, obviously, when you're actually encrypting it to be consistent, the content type in the HTTP headers will always be application JSON. However, the content encoding would be gzip. Now, in OPC UA, we have a distinction between what we call our sessionless services, where you don't need to store any server-side state. So these services are well suited for using in any sort of server farm scenario where you don't want to have to remember the client state from call to call. And then we have the session-based services where you need to have state for them to function, client state stored in the server in order for them to function properly. The sessionless services are useful for a number of simple applications. In particular, the call service um, gives you a standard way to extend an information model in order to add custom behaviors, and they're well suited to invocation with a sessionless service call. Browse and translate and read, they can be used as well depending on what you're trying to do. You should not be using the sessionless services for anything that looks like a subscription, because doing pulled reads on a sessionless service you're gonna run into performance issues depending on how fast. You should always assume that as soon as your requirements require some sort of subscription, then you need to move to session-based services by creating subscriptions and monitored items. Obviously, that's going to limit what you can do in terms of running in a server farm, but with a properly designed server, there's no reason why you couldn't also have persistent subscriptions stored in some sort of backend database that get restored every time a client reconnects, potentially from a different server instance. Now, session-based servers are actually best used with WebSockets, and I'll talk a bit how we handle the integration with WebSockets. So with WebSockets themselves, now the OpenAPI definitions don't have any WebSocket option. However, they do define the request and the response format. So you basically use the OpenAPI definitions to tell you how to format the request or the response, and you send these things out over a WebSocket. And we've defined a sub-protocol to basically tell the server what's coming in there, so you can multiplex your web sockets. You can support different kinds of data. Binary frames are gzip encoded. Text frames are JSON encoded. Any session-based API you should use WebSockets. Now, in real-world applications, there are plenty of examples of different WebSocket frameworks, or basically stuff built on top of it, such as SignalR, which are preferred by a lot of applications. The same connection could be followed, the same design pattern can be followed. You take the OpenAPI request and response, and you send them over whatever higher level construct you have, and everything should work otherwise. And the only thing you need to have a certain amount of control over both sides, because obviously you're not going to get the multi-vendor interoperability if you're using something like SignalR. But it's going to be useful in some circumstances, depending on what you're trying to do. Now, in order to confirm for ourselves that all the different pieces that we're pulling together sort of work as expected, we've been developing a TypeScript web client, which is currently in GitHub. This is just a simple application that browses the server and displays the contents of the node. In certain cases, we have, based on the type definition, we have a special card that comes up, which is what you see here. It allows you to subscribe to everything that's on the card, and you'll automatically get updates. Um, in this case, if you're using any sort of subscriptions, you're using the WebSockets, but the actual browsing, sort of jumping around the different nodes, that's all using the simple REST. So you can seamlessly switch between REST and HTTPS and WebSockets, depending on what you're trying to do within your web application. Obviously, if you want to remember session context with your reads, you want to be using the same WebSocket if you want all the traffic to go through a single session. But the user authentication, whether you're using WebSockets or whether you're using whether you're using HTTP requests, is all going in the authorization header. Now, all of this code is sitting at GitHub in the UA REST Starter Kit, member only for now. In the next 6 weeks, we're cleaning it up and we're going to try to add some support for additional languages in addition to TypeScript, preferably, well, like definitely JavaScript, preferably Python, maybe Java, depending on time. And we'll make these all available to public under the MIT license. The server side, we've integrated it in with the .NET SDK because that was just a convenient. On the client side, no special libraries required, built entirely with the auto-generated code from the OpenAPI generator, and plus the constants files, which have all the different node IDs. So all licensed under MIT, and it should be a very handy platform for people to get a REST application up and running very quickly, and give you some idea how you can do and how you can leverage this exciting extension to OPC UA. So I'd like to thank you very much for your time listening to the talk. If you have any questions, I'll be answering them. Just put them in the chat, and I will be answering them as they appear. And I hope you all have a good day.